8-2, linear equations in two variables. In this section, and then for the rest of the chapter, you're going to be working with equations that have two variables. They will always be an x and a y, and they will be an x and a y for a reason. As you saw in the last section, 8-1 in functions, x's and y's were coordinates for putting points on a graph. The rest of this chapter will be continuing work with solving equations to put points onto a graph. So here we have linear equations in two variables. You actually did this work as well back in chapter 2, but we didn't mention the linear equations in the two variables. We just had you set up some problems and solve them. And you're going to do things the exact same way. So hopefully the only thing new today will be the terminology that goes along with the work that you need to do. One thing that's very important, that's helpful now, but will be required in two sections from now, is to always solve the equation for the variable y. So we want the variable y on the left-hand side of the equal sign, and then everything else on the right-hand side of the equal sign. It should look something like this. Y equals some number times x plus or minus some other number. So we will actually solve one of them that way, and then one when we're not going to do it, because if you're not comfortable trying to get it that way, you'll at least have the ability to set up and solve the equation. So we'll look at the one on the left, and we're going to simplify that one, which is 4x plus y equals 2. We want to get the y all by itself, so we will subtract 4x from both sides of the equation, and the 4x's on the right-hand side cancel each other out, leaving us with y equals 2 minus 4x. This is close to the way we want it to look, but it's not exact the way we want it to look. So we need to do some work, and we're going to rewrite it as y equals negative 4x plus 2. So that's going to be one of our equations. And the other equation we're going to leave as 3x minus y equals 10. So we'll move to the next slide, and we'll take our first equation, y equals negative 4x plus 2, and our other equation, which was 3x minus y equals 10. 3x minus y equals 10. So at this point, once you solve for the variable y, you're going to follow the directions and find 4 ordered pairs solutions by picking 4 values for x. You can pick any values you want for x. It's entirely up to you. However, negative 1, 0, 1, and 2 are the best ones to choose simply because doing math with those numbers really close to 0 is usually easier than picking things like 3 3/8, negative 7 million, and numbers like that. You can also look ahead and know something about the equation you're working with and pick other numbers to make the ending solution, the y value, easier. But either way, you want to keep things close to as 0 as possible, because later we're going to actually put these 4 points on a graph. So at this point, we're going to do 4 little math problems. So we're going to have y equals negative 4x plus 2, and we're going to pick our values for x to be negative 1, 0, 1, and 2. So we'll substitute in negative 1 for x. Y equals negative 4 times negative 1 plus 2. Simplifying that, y equals 4 plus 2, so y equals 6. So when x is equal to negative 1, y is equal to 6. We will do this problem again, but this time times 0 plus 2. Simplifying, y is equal to 0 plus 2, so y equals 2. So when x equals 0, y equals 2. Doing a third simple math problem, y equals negative 4 times the positive 1 this time, plus 2. So y equals negative 4 plus 2, and so y equals negative 2 this time. So when yx equals positive 1, y equals negative 2. And then we'll do this finally a fourth time, but this time we will substitute in 2 for x, and simplifying it, negative 8 plus 2, and we get y equals negative 6. So when x is 2, y is equal to negative 6. Now, you might be looking at that and seeing the positive 6, the positive 2, the negative 2, and the negative 6, and notice a pattern that way. That's a coincidence. It just happens to work out that way for this example. So, for the equation y equals negative 4x plus 2, we have our table of values from the previous slide where x is negative 1, y is 6, x is 0, y is 2, x is 1, y is negative 2, and when x is 2, y is negative 6. We were actually going to take these four values and we're going to put them onto the graph. So the first coordinate is going to be at negative 1, 6. So we go over to the graph to negative 1 and up to 6. 2, 4, 6, and we put a dot at negative 1, 6. The second dot goes at 0, 2. Go over to 0, up to 2, and we put the dot. The third dot is going to be at 1, negative 2, over to 1, down to 2. And the fourth dot goes at 2, negative 6. And you should notice something at this particular point in time. Those four dots should make something. They should make a line. And we will actually put a line in through those four dots, just like that. It can be a horizontal line, a vertical line, or a diagonal line. Regardless of what kind of line it is, you will always end up with a line. I'm going to go back to the first slide for a second. And we have 8-2 linear equations in two variables. This y equals negative 4x plus 2 is a linear equation in two variables. It is an equation that makes a line. So all of your work in this chapter from now on is going to make lines, straight lines.